In this video, I walk you through a case study on the intelligent document processing using large language models and serverless technology. This is a common challenge for companies dealing with the unstructured documents, and I will show you how we can solve this logically. So the scenario is as follows. The company received thousands of invoices, receipts, and expense reports in various formats such as PDFs and images. Those documents contain spending categories, vendors, transaction dates, and amounts, but their structure is inconsistent, making the traditional extraction methods ineffective. Your task is to design a solution to extract spending details into a structured format. As the data volume varies, so the solution is required to handle the changing processing demand. The data is used to generate a dashboard report in the end for the finance team. So feel free to pause the video to think about the solution before continuing. Now let's dive in and break this problem down step by step. The first step is solving the problem is to identify the main challenges. In this example, the challenge is to determine whether the documents are structured or unstructured, as this defines our extraction approach. Structured documents like invoice follows a predictable format, making them easier for traditional OCR tools. On the other hand, the unstructured documents like scan receipts, the format varies, making the extraction much harder. Traditional OCR extracts text but lacks context. That's where the large language models comes in. Unlike OCRs, a large language model understands meaning, linking values like a spent item and a spent amount in an invoice together. Therefore, it is able to convert the unstructured data into a structured format. Now that we've identified the challenge, to extract the meaningful data, we need the right AI tools. This is where the foundation models comes in. So in the second step, we are required to choose the correct large language models for the task. Unlike a traditional OCR, foundation models like Claude 3 is a multimodal, which means that it's able to process both text and images, understanding documents context, layout, and data relationships. But to use those models effectively, technical experts is key. A strong understanding of different large language models is essential. Each model has strengths, and choosing the right one impacts accuracy and efficiency. Equally important is the prompt engineering. A well-crafted prompts can guide the models to extract the structural data with high precision. For example, the text total amount equals to $200 in the original invoice may appear in a table format or as a plain text or even as handwritten content. Um, Now let's see how we can integrate this with service processing in a scalable automated workload. So with the model finalized, the third challenge is processing inefficient and scalable processing. This is where the serverless technology comes in. This is a key component. This is a key component of the solution, so I will spend a bit more time on this. For example, with AWS Lambda, we can automate a document processing at scale without managing servers. Lambda can be triggered whenever a new document arrives in S3 buckets, and the Lambda will process the file and send it to the large language model API for data extraction. So why do we choose serverless? There are mainly three reasons why we consider it in our design. The first is scalability. Serverless solution like AWS Lambda automatically scale based on demand, whether you are processing a few invoices or thousands. Lambda spin up multiple instances in parallel, ensuring quick processing without manual intervention. This makes it ideal for handling fluctuating workloads. The second is cost efficiency. Traditional servers require provisioning and maintaining infrastructures, which can be costly. especially during the low usage period. With serverless, you only pay for the execution time, meaning business avoids the expense of idle server capacity. This pay-per-use model is especially beneficial for workloads with variables and unpredictable processing needs. The third important point is the easy integration. AWS Lambda is natively designed to work with other AWS services. It can be triggered by S3 based on the event-driven approach. It can store the extracted data in DynamoDB or RDS or other database services, and it also can expose the data, the database data, via the API gateway. So to sum up, right, AWS Lambda enables a fully automated workflow with a minimal setup. So together, um, large language model and service computing, we're able to design a fully automated, cost-effective workload for intelligent document processing. Once we've extracted structured data, the next step is to store in a way that supports efficient dashboarding and reporting. Given the flexible nature of the extracted data, DynamoDB is a strong choice for storage since the data schema can vary based on the document types and the content. DynamoDB's NoSQL structure allow you to store this data without a rigid schema requirements, supporting the dynamic nature of financial documents like invoices and receipts. It also provides a fast querying for real-time insights, essential for building an interactive dashboard. So while Amazon S3 can store raw documents and the RDS is ideal for complex query, DynamoDB shines here when you need to handle variable unstructured data and query it in real time for dashboard updates. And lastly, we can choose the right BI tools depends on your business preference. Now I'm using the AWS to demonstrate a sample solution covering the key steps explained in detail. Here, I'm using sample income and expenditure statement with a tabular layout. We assume there's another data ingestion service that sends the data into AWS S3. Once the data is stored in the S3 buckets, the EventBridge triggers the Lambda function for data extraction. The statement contains two categories, income and expenditure, with data for two separate years, 2007, 2008, listed in the columns here. You can see that the large language model process and extract the correct informations into the structured JSON format, which can then be ingested into the downstream database for dashboarding purpose. So to implement this solution, the technician needs to have a sound knowledge in cloud services like AWS, large language model for data extraction, a serverless architect, and integrating data for dashboarding and reporting. Well, we've covered the main aspects of designing the data extraction and the storage part of the project in the cloud. There are several critical areas that often gets overlooked. In practice, those considerations play a vital role in ensuring a secure, scalable, and maintainable solution. So the first point I want to point is the software development best practice. So data science projects in the cloud aren't just about models, they are software solutions. That means applying best practice like version control, modular coding, and CI/CD pipelines. Writing maintainable code and following software engineering principles help ensure long-term project success. Second is the DevOps automation. So cloud-based projects benefits greatly from the DevOps methodologies. Infrastructure as a code, using tools like, say, in AWS you have CloudFormation or Terraform, allow for repeatable and scalable deployments. Automated testing, CI/CD pipelines, and containerized, for example, Docker or Kubernetes, streamline operations, making model updates and deployment seamlessly. Permission roles and fine-grained control access. This is part of security. It's paramount. So implementing IAM roles, least privilege access, and identity federation ensure that only authorized users and services can access specific data and the models. This reduces the risk of data breaches and unauthorized modification. Networking and VPC is also very important. Placing the project resource within a virtual private network, virtual private cloud, provide control over how data flow between services. So private subnets, security groups, and network access control list ensure that sensitivity operations happens in the controlled environment. So if integrating with on-premise systems, VPN or using AWS Direct Connect may be necessary. So in practice, many companies won't even allow to deploy any services but within their VPCs. So next part is the encryption data protection. So when working with large language models, protecting sensitive data is critical. Cloud storage service like S3 supports encryption at rest and in transit. Using AWS Key Management Service ensure that secure key handling, while anonymization technologies help mitigate risk when processing personally identified informations, PII. This is especially important when large language model interacting with financial, healthcare, or customer data, where compliance and privacy regulations must be met. Monitoring logging observability is also important. So logging helps to track performance, detect abnormalities, and debug issues. So proper logging ensure compliance and provides insights for troubleshooting. The last part is throttling error handling. So working cloud, a lot of solutions offer interacting with multiple APIs. So including the large language model services, the rate limit can lead failure if not handled properly. So implementing retry logics, exponential backoff, or circuit breakers can improve system reliability while managing costs effectively. So this can be a part of software development best practice. That wraps up today's talk. So we explored a case study and build a serverless solution, leveraging large language model APIs for advanced document processing. Thanks for watching, and I hope this gives you a valuable insight into designing scalable AI-driven solution in the cloud.